Hello guys, welcome back to my YouTube channel. So in this section we're going to be talking about the law of conservation of linear momentum, which states that where in a closed or isolated system, when two bodies collide, the sum of the momentum before collision is equal to the sum of the momentum after collision. In this law we derive two things, which is momentum and two bodies collides. So this momentum is the product of mass and its velocity. So momentum is equals to mass times velocity. Why this is two body colliding. Just imagine when two cars hit themselves is an typical examples of collision, or when gas particles colliding in a container. So we have types of collision, which is elastic collision and inelastic collision. Let's talk about elastic collision. Elastic collision occurs when the body collides and move in opposite direction after collision. When two bodies collide and move in opposite direction after collision. So from this we have that two bodies colliding, let's say A and B, they collide in opposite direction. B is coming from here while A is coming from here, with a known mass and a known initial velocity. This is the second mass and this is the velocity of B. These two bodies are colliding. So this law says that the sum of the momentum before collision is equal to the sum of the momentum after collision. So before collision, this is before collision, and this is after collision. A moving with a common velocity and a known mass, B moving in opposite direction and with a common velocity and a known mass. So from this we can derive the formulas which are m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. So this here is before collision, as you can see in the diagram, and here is after collision. So from here now we can now derive the formula, which is m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. This is for elastic collision. So let's move over to inelastic collision. Inelastic collision occurs when two bodies collide and after collision they move with a common velocity. So in inelastic collision we have types of inelastic collision. 1. Inelastic collision of a stationary body. 2. Inelastic collision of a body moving in the same direction. And 3. Inelastic of a collision where one of the velocity is greater than the other. Let's look at the example. The first inelastic collision is both of them moving in opposite direction. So A, they are moving in opposite direction. A is moving with an initial velocity with a known mass, and B is moving in opposite direction to A. So both of them will collide. So if these two bodies collide, what will happen? We are talking about inelastic collision. If this was elastic collision, they will just move in separate ways after collision, but it is inelastic collision, which means that the momentum of A is greater than the momentum of B. So after collision they will now move in this direction. A and B moving in this direction with what? With their masses and the common velocity. So from here we cannot derive the formula, which is m1 u1 plus m2 u2 plus m2 u2 is equals to m1 v1 plus m2 v2. So we now have m1 u1 plus m2 u2 is equals to, because they are moving in what? In a common velocity. So we have v is equals to m plus 2. So this is for inelastic collision of two bodies moving in opposite direction. So let's talk about inelastic collision of two bodies, one in motion, one is not in motion. So A, as we can see here, is moving with an initial velocity and a known mass, and B is stationary. B is stationary. So when a body is stationary, which means it is not in motion, is 0. So it has initial velocity of 0, is with a known mass. So this is before collision. So after collision, what will happen? After collision, they will move in the same direction with the same velocity, which means that A and B will move in the same direction with the same common velocity with their masses. So from here we can now derive that m1 u1 plus m2 u2 is equals to v bracket m1 plus m2 for a body in stationary. But since this body in stationary, remember that momentum is what? Mass times velocity. So y here is the initial velocity. We can also write this formula as m1 u1. m1 u1 is equals to v bracket m1 plus m2. Like writing it like this is also correct, because here the body is stationary, so it is 0. Whether you add it or not, the momentum is equals to 0, so it's not necessary. You are preparing for an examination. Writing the formula like this is very important to prove that you know what you are doing. So let's talk about inelastic collision where one is greater than the other. So let's say A and B moving with an initial velocity and mass, with B moving in the same direction and initial velocity and also a known mass. This is before collision. So for these two bodies moving in the same direction with different velocity collides, which means that this mass must be greater than this one, the momentum of this one must be greater than this one, the velocity must be faster than this one before an inelastic collision like this can take place. So if these two bodies collide, we have A and B. They will move with a common velocity, which is the final velocity, and masses m1 m2. So from here we can now write m1 u1 plus m2 u2 is equals to v bracket m1 plus m2. We have this formula because m1 u1 is greater than m2 u2. This is why we have this formula for inelastic collision moving in the same direction with different velocity. Then after the collision, they will now move in the same direction.